Hey everybody, welcome back. Today we are going to extend our lesson on 3.5. This is the second half of it. We're going to talk about slope-intercept form. Now, there's a chance maybe you've heard about this in 7th grade, but I do not know exactly, especially with how crazy last year was. This is actually something the regular math kids have already learned. It's kind of weird. Our classes are almost kind of crossing paths right now. But anyway, this is probably the most commonly used method to write the equation of a line, slope-intercept form. And on my board right now, this is the format. Math people aren't always the most creative. If I was more creative, I might be like an art teacher or a drama teacher. But you can see the name is slope-intercept form, and look at the order of the information that it tells you. It tells you the slope, and it tells you the intercept in that order. They weren't very creative. They just said, hey, let's call it slope-intercept form because it tells you the slope and the y-intercept. I guess I should have been more specific there. The letter M, I mentioned that in yesterday's video, is always used to represent slope. So whatever the coefficient, remember this is the coefficient, whatever the letter x is being multiplied by, that is the slope. If there's no number there, it's going to be obviously a 1, imaginary 1, but usually there's a number that the slope is being multiplied, or that the x is being multiplied by, and that coefficient, the letter m, is called the slope. And then there's usually a part at the end adding or subtracting. It doesn't have to be a plus sign. An adding or subtracting part at the end, and that is the y-intercept. The y-intercept is where the graph crosses the y-axis. So here's some examples I made. You can kind of just do a quick little glance. Excuse me. These over here are the most typical. Like this one has a slope of 1/2 and it has a y-intercept of 5. So like this graph would start at 5 on the y-axis, and then it would go up 1 over 2, up 1 over 2. That's how the 1/2 comes in, right? Up 1, 2 to the right, up 1, 2 to the right. The second one would have a slope of 2. It would start on the y-axis at the point 3. So it would start at 3 on the y-axis, like somewhere up here. It would start at 3, and then it would go up 2, and then there's no number on the bottom, so it's imaginary 1. It would go up 2 over 1, up 2 over 1, kind of like that. And we'll graph more of these here in a minute. I'm getting ahead of myself. I just want to kind of give you a visual of what they look like. They don't always have to have positives, right? You can have a negative slope. That's a line that goes down. Here you have a negative slope and negative y-intercept. So this y-intercept number doesn't have to be positive, right? The graph could start way down here at -6. 1, 2, 3, 4. It could have started like way down there and then gone whichever way for the slope. Sometimes they won't put a y-intercept at all. Like this, it just says 3x, and technically your y-intercept is +0. They don't ever write it. That type of situation, the graph would start at the origin, right? It would start right at the origin, right here in the middle of the x and the y-axis, and then this one would go up 3, 1 to the right, up 3, 1 to the right. If they don't put a number on the slope, it is a 1, imaginary 1, like right there. And then these last two, I've never heard it called this, but our book called these two. You see how this doesn't have a slope at all? It's just y equals 6.5 or y equals -2. This is almost like 0x plus 6.5, right? That would be the same thing. These two are identical. They just don't put the 0x. This is the same thing as y equals 0x minus 2, right? So right there in that little circle, those are the same thing. They just don't ever put it. Those, remember, are straight lines. Those lines are going to be completely horizontal. Y equals 6.5 would be like way up here at 6. It would just be going straight across at 6.5. And then y equals -2 would be right here going through -2 straight across. Our book calls these constant functions because it's a horizontal line. Now, I've honestly never really seen that anywhere else. I can't remember ever seeing it on a test. But if you do happen to see it on a question, what is a constant function? A constant function in this scenario is something that is a horizontal line. It does not have any slope. The slope is 0. Okay, enough of that. Let's see what the questions will actually look like. All right, here's what your questions are actually going to look like. Well, you know what? Let me save this one for next. Let me do this one first. Find the slope and the y-intercept. Okay, easy, right? Remember, you've got this format, y equals mx plus b. And if it's in this format and it's written perfectly, you can just pick it out, right? This is the slope, the m. This is the y-intercept. And this first one is very straightforward. It's basically just showing you exactly, this is the perfect scenario because it's in the perfect format. Look, the slope is right here, the number that the x is being multiplied by. So on this one, I would say the slope is -6. And then the y-intercept is the adding or subtracting part at the end. In that case, it is +1. Make sure you take the symbol in front of it here, +1. So I could write y-intercept, or I could just put b. I could say the m is -6, the b is 1. Perfect, done. Easy. This one is a little tricky. This is one of them that I just talked about, one of those constant functions, because it doesn't have a slope. This is the same thing as 0x plus 8. Notice I put plus because this was positive 8. If this would have been -8, I would have put a minus there. So in this situation, the slope is not there. There is no letter x. If you don't have a letter x, you don't have a slope. The slope is 0. This is one of those flat lines, completely horizontal. The y-intercept is 8. Done. Easy. Takes what, 5 seconds? Here, they were a little bit more rude to you. On letter C, I'm actually going to have to work this one out, right? They didn't put it in slope-intercept form. Do you see what slope-intercept form looks like up here? The letter y is all by itself on the left-hand side, completely isolated, right? So to do letter C correctly, the first thing I need to do is get the letter y isolated on one side of the equal sign. And we've done this before. We're going to solve this for y. We want to get the letter y all alone. What is happening to the letter y? Well, right now it's being multiplied by 4, and it's being added with the x. So I want to undo that, right? This should sound familiar. We did this a while ago. How do I undo addition? Remember, undo the adding and subtracting first. Instead of adding x, I want to do subtracting x. Whatever you do on one side of the equal sign, you do the same thing on the other side of the equal sign. X minus x is nothing, so I just have 4 times y. Over here, I kind of want it to look like this. I want the x part to come first and then the y-intercept to come last. So I could write -10 minus x if I wanted to, but I actually like doing it this way, -x minus 10. It's technically the same thing. It's not going to be messed up. But I like to have that x part first just so it kind of matches my format here. Okay, the last thing I need to do, the letter y is still being multiplied by 4. I need to divide by 4. And you divide every single term, right? Every single one. And look what we have. We have -x over 4. That looks a little bit awkward. Just put a 1 on there. It's kind of like -1/4 x. And then 10 divided by 4. I could take out a calculator. I believe that's 2.5 or 2.5. Excuse me. So I'm going to have this as my kind of corrected slope-intercept form. I really didn't answer the question, though. Which one of these numbers is the slope? The slope number is the one that the x is being multiplied by, the coefficient on the x, -1/4. So on this one, my slope is -1/4. Could you put -0.25 and make it a decimal? Sure. But most people do slope as a fraction. The y-intercept is this at the end, negative, because it has subtracting, -2.5. Could I call that -2.5? Sure. It looks a little weird because one's a decimal and one's a fraction, but you could do that. You could do 2.5. You could even say -5 over 2. That would be fine as well. Okay, one more on here, and then we'll move on to the next board. I'm going to try to make this a little bit faster than yesterday's video was. Now, this is the same scenario on letter D. This is not in slope-intercept form, so I'm going to write this over here to give myself some room. We need to get the letter y isolated all by itself on the left-hand side. All right, right now the letter y is wanting to look like this, but right now we got all this other stuff around it. So one thing you could do is, I kind of like having the y on the left instead of having the letter y on the right. So I'm actually going to do adding y on both sides. This is kind of weird. You've never really seen me do this before. Normally you might say you would do -8 on both sides. That would work as well. But I kind of like having the y on the right-hand side. Or excuse me, the letter y on the left-hand side. Because look what you get. Y minus 5x, right? I didn't put a plus on here because if it's just a y, it's the same thing as being positive. Minus 5x equals 8, because negative y and positive y cancel each other out. And now I need to look again. Now the letter y is being subtracted by 5x, so I want to do adding 5x and get the x out of the way on the left-hand side. Notice how I wrote that there. That was kind of sneaky of me, right? I didn't add these up and get 13. No way, Jose. You can't add these because this has an x on it, and this is just a regular constant. You can't add these together because they are not the like terms. Remember, our format has the letter x come first, and then the y-intercept comes last. And so I actually want to put this first. I'm going to put 5x, and then this is a positive 8, so I'm going to put plus. If this would have been a -8, I would have had to put a minus right there. Now, this format looks much more like this up here, right? Now it is in slope-intercept form. I can see the slope, 5. I can see the y-intercept, +8. And so I can write that right here. The slope is 5. The y-intercept is 8. Done. Easy. All right. Those last two are about as tricky as they can make. That's what most of your questions are going to look like today. On some of the other ones, they'll actually have you graph these. Okay, now how do I graph these? The good news is, if you're doing it on a computer, which all of you are, the computer screen already has the graph drawn for you. I don't have one drawn for me, so this is going to be a little bit of an annoying process, but I can do it. Look, I know the slope. The slope is 4, and I know the y-intercept. The y-intercept is right here. It is -4. See how that's subtracting? So I know some things about this graph. Let me do a quick little graph right here. Probably should have done this in advance, but I did not. That's okay. I'm just going to go to 5 each direction just to kind of save a little bit of time without making this go too lengthy. Okay, so I have my graph. I know that I would need to graph this one on the coordinate plane. Start with the y-intercept. The y-intercept is the starting point of your graph. I used to say this all the time in regular math. The end of the equation is the beginning of your graph. I can't do the slope first because I don't know where to start, right? The y-intercept is a starting point. This graph crosses the y-axis at -4. So I'm going to go down here to -4 on the y-axis. Remember, this is the x-axis, this is the y-axis. So I'm going to go to -4, boom, crosses the y-axis right there at -4. Okay, I took care of that part. Now I need to look at the slope. The slope is 4. That's the same thing as 4 over 1, isn't it? So I'm going to rise 4. I'm going to run over 1. I'm going to rise 4. I'm going to go up 4 over 1. Up 4 over 1. Let me do it here really quickly. Start on this dot. Up 4. 1, 2, 3, 4. Over 1. Right there. And then do it one more time. My teacher always told me you need 3 points to make a line, so I'm going to do one more. Up 4 again. 1, 2, 3, 4. Over 1. Perfect. Up 4 over 1. I did it. I connect it. There's my line. And look what the question said. Graph the equation. Perfect. I did it. Find the x-intercept. The x-intercept is where this graph touches the x-axis. My graph touches the x-axis right here at the point 1. This doesn't have like a cool abbreviation. There is no like, you know how we abbreviated the other one with the letter B. This one doesn't really have an abbreviation. So I'm just going to say the x-intercept is 1. And there you go. That's it. Okay, let me go ahead and do the next couple. I can already tell now this video is going to get a little bit lengthy again. I'm so sorry about this. All right, let's do this next one. This one is not in slope-intercept form. That is rude, disrespectful. All right, I can make it work. I want to get the letter y all alone. So right here, the letter y is being added with the 3x. So I want to undo the adding with subtracting. I'm just going to do it right here. I should have space. 3x minus 3x is 0. That goes away. And I'm left with this. Y equals, now this is kind of backwards. Remember, in our slope-intercept form, the x comes first. So I'm going to put the minus 3x first. And then the plain old number, the minus 3, is going to go right there. So here's my equation. We have another one where the slope and the y-intercept are almost the same number. That doesn't happen very often. But I should be able to graph this one now. I can tell just by looking at the graph what I wrote in green, looking at my equation, sorry, not the graph, that this one has a y-intercept of -3. See how it has -3 at the end? Right here. So I can tell I'm going to start at -3 on the y-axis. So on my y-axis here, I'm going to go to -3, perfect dot right there in purple. That's what this tells you. This is the y-intercept. And then the slope is also -3. That doesn't happen very often. That's the same thing as -3 over 1. So that's a clue that I'm going to go down 3, 1 to the right. And I don't have room to go down 3, so let me extend this out one more time. I'm going to go down 3, 1, 2, 3. Always go to the right. If you're not going to the right, you're doing it wrong. Now I could kind of freehand this one. Down 3, over 1 more. I never made it to the x. How do I find the x-intercept if my graph? People do this, and they're like, well, it doesn't touch the x-axis. Well, yeah, it does. You just didn't make the line long enough, right? So if I kind of follow this pattern, maybe I go, instead of going down 3 and 1 to the right, maybe I do everything backwards. Instead of going down and to the right, I can go up and to the left. As long as you do everything backwards, it'll still work. So I could go up 3 and 1 to the left, and look where I am. Whoops, I didn't connect my line very straight. There it is. So if the slope ever is like that, where it takes you away from the x-axis, and you need to figure out the x-intercept, you can see this one is right here, -1. The x-intercept is -1. If you ever are following the slope down 3 over 1, down 3, and you're never going to hit the y-axis or the x-axis, do everything backwards. Instead of going down and to the right, go up and to the left, and you'll still be in the right spot, right? Up 3 over 1, up 3, we'd still be on this line. Okay, you know what? I'm going to I'm going to stop right there. I'm not going to do letter C because that's going to take too much time. I want to do one word problem here. I decided to challenge you guys, and I'm going to put like 2 word problems on this assignment just to test your skills, see how advanced we can really be here. I made this up. This isn't like one in the book. It says the function shown models the money, M, that you spend during the first 6 hours, H, of Cyber Monday shopping is this. M parentheses H equals 30H plus 50. Okay. Letter A, graph the function and identify the domain and range. Then B, identify the slope and the y-intercept. Okay, here is my graph. I did make this graph ahead of time, if I don't smear it by putting the thing right there. Okay, here's my graph. It says this function shows the amount of money you spent during the first 6 hours of Cyber Monday shopping. Okay, if I look at my equation right here, this is my y-intercept number. So my graph is going to start at 50, positive 50, and then the slope is right here. The slope is 30. So this graph is going to go up $30, and then it's going to go over 1. But it's going to start at 50. Start at 50, and then it's going to go up 30 over 1. Up 30 over 1. So graph the function. I'm going to start at 50. That's my y-intercept right here. Boom. And now, remember, our slope was 30. 30 over 1. So I'm going to go up 30. So if I'm at 50, I'm going to go up 30 more. That would give me to 80. Up 80 over 1. And then do it one more time. Up 30 more would get me to 110. I go over 1 hour. I could even do one more, up to 140 and over 1 hour. Okay, be smart about this. Should these dots be connected or should these be separate dots? Is this continuous or discrete? Look at what you're measuring. Your independent variable is hours. Can I have a fraction of an hour? Could I have a decimal of an hour? Of course you can. So if you can have fractions and decimals, it is continuous data, right? Continuous, this is a continuous domain, and we could connect the dots. Okay, I didn't actually go all the way to 6 hours. If you remember the question says graph the function. I just did that. Identify the domain and range. So the domain and range is going to be a little bit tricky because, look, this question very specifically said the first 6 hours. So if I'm only doing the first 6 hours, my domain, I'm just going to do D for domain, is going to be all the numbers from 0 to 6, right? Remember to use those less than symbols when you do this. I could shop anywhere from half of an hour, a third of an hour, an eighth of an hour, all the way up to 6 hours because this question specifically said the first 6 hours. Now, what is my range? How high would this graph really have gone? I didn't actually make it go all the way to 6 because I ran out of space. But if we had this equation, let me write it here just so I don't have to keep flipping it onto the screen. If I had this equation, we only did 1 hour, 2 hour, and 3 hours. What if I did all the way up to 6 hours? How much money would we have spent after 6 hours? If we put a 6 right here and for the H, well, if you put a 6 right there, look at how much money you would have spent. 180 is the answer here, right? 180 plus 50. So if I put 6 in here, my answer really would have been 230. Remember how you write that? M with a parentheses 6 means I plugged in 6 for the variable. So my range would have been all the way from where this graph started, right? At 0 hours, I had spent $50. I apparently had already spent $50 before I even started shopping. And then my high amount, if I had spent everything all the way up to 6 hours, it would have gone all the way up to 230, and that should probably not be an X, probably should be a Y, or you know what, it's actually an M because we were talking about money, all the way up to 230. Okay, that's the domain and range. There's one more question, and then I promise I'm done because I'm almost at 20 minutes. Identify the slope and the M-intercept, not the y-intercept. This one's kind of funky. It's called the M-intercept because my equation has an M in it instead of a Y right here. But don't let that bother you. Identify the slope. Easy. Look, it's right here. The slope is 30. So the slope is 30. That was also shown on our graph because it's going up $30 over 1 hour. For every hour, we're going up $30. What is the M-intercept? It's typically called the Y-intercept. But if they ever do something funky and call it the M-intercept, because over here you technically have money, right, that starts with an M, where did this cross the y-axis? Right there, 50. So my M-intercept is basically where this graph started on the y-axis. and that was $50. So you'd already spent $50 in your account before you'd even started shopping on Cyber Monday. Maybe you'd spent some money on Black Friday or something. So there you have it, guys. 20 minutes. Sorry about that. I'm going to post some videos on the Big Ideas Math site. Hopefully you can be successful. As always, email me or Ms. Boseller if you need help on it, and I will catch you guys in another video tomorrow. Have a good one.